Alright students, today we're going to talk about 2011 number 6. And this problem has to do, in just a quick glance of this particular problem, you will notice that this probably has to do with continuity, and it's a piecewise function, and so on. And in fact, there's one term that's been put here in part C, which is average value. So you need to remember the average value formula for the calculus problems. Okay, let's start out. Let's start with the number 1. Let's start out actually by writing out the function. The function is f of x is equal to, and this is a piecewise function, 1 minus 2 sine x, and this is for x is less than or equal to 0. And on the positive side, f of x is defined by e to the negative 4x, e to the negative 4x, for x is greater than 0. So on positive side is this, and negative side is that. Part A says we want to show, or ask us to show, that f is continuous at x equal to 0. At x equal to 0, f is continuous, and we need to show that. Now, if you remember, there are two criteria for continuity. Continuity requires that one, f of c has to exist. So that means f of 0 we have to have f of 0. Right? Second one is that the limit as x approaches c from the positive from the negative perspective, or negative side of f of x, has to equal to the same thing as x approaches c from the positive side for f of x. Okay, if that's the case, let's try it out. F of c. Does f of c exist? So let's go to here. Number 1. Does f of c exist? Meaning, does f of 0 exist? Well, let's try it out. Well, the only place that you can use it is you can only use on this one. Why? Because x is less than and equal to 0. This says x cannot, this is x bigger than 0 but not equal to 0. So we're going to use this part. So we say, okay, now let's put 0 in here and see if we actually have a value. If we have a value, that means f of 0 exists. So we put this in here, in this equation, 1 minus 2 sine x. So 1 minus 2 sine 0. Now sine 0 is 0. So 1 minus 0 is 1. So f of 0 is 1. Check. Right. F of 0 exists. Good. 2. Now we need to figure out if the limit coming from the left side is equal to the limit coming from the right side toward 0. So f as a limit of x approaches 0 from the negative side of f of x. Now we need to figure out whether this is actually equal to, so I'll put a question mark right here, limit as x approaches 0 from the positive side for f of x. So this one, then we will use this. So we will say from 1 minus 2 sine 0. Now when you see if that's equal to e to the negative 4 times 0. It turns out this is 1, turns out this is 1, so they're equal to each other, and therefore we can say f is continuous at x equal to 0. Done. That's part A. Okay, let's talk about part B. Let me erase part A. Okay, so take a moment to look at this. You may be able to pause it, or you may be able to rewind it. Part B. Part B says, for x cannot be 0, x not equal to 0, express f prime, right, the derivative of f of x, as a piecewise function. And after you have done so, we need to find the value of x. So we need to first of all find this. And then after that, we need to find x when f prime is equal to -3. So we have two parts for this problem. So let's do the first part. The first part is very easy. F prime is equal to, so we'll take a derivative on this. Derivative of 1 is equal to 0. Derivative of -2 sine x is -2, and then derivative of sine x is cosine x, so it is -2 cosine x for x less than or equal to 0. You know, in fact, not equal to x less than 0, because x cannot be 0. Derivative of e to the -4x is e to the -4x times the derivative inside function, which is -4, so times -4. So it's -4 e to the -4x, x greater than 0. So here we have it. We get 2 points right there for coming up with that. Now, we need to figure out the x's, or if there's the possible x values for f prime equal to -3. Now first of all, let's take a look at this one. -2 cosine x, and then we want to say that this has to equal to, is it possible to have this? Well, let's take a look at this. Well, first of all, x has to be less than 0. X has to be less than 0. So we're looking at the cosine graph on the negative side. But regardless, cosine goes from as high as 1 to as low as -1. So you take any value between +1 to -1, multiply by -2, you will never get anything close to -3. So it's not going to be possible. So that one, gone. We're not going to consider this part. But what about this part? Is it possible to have -4 e to the -4x equal to -3? Well, absolutely. Take a look at this. We divide both sides by -4, we get e to the -4x is equal to 3/4. Right? -3 over -4 is equal to 3/4. Now we can ln on both sides. When we ln on both sides, we get -4x is equal to ln 3/4. And so x is equal to ln 3/4 over -4. And ln 3/4, we know that ln 1 is equal to 0, so ln 3/4 is less than 1. 3/4 is less than 1, so ln of anything less than 1 is going to give you a total value of negative. Negative over negative is always going to be bigger than 0. Makes sense. It fits into this domain. So there you have it. Here is the value. X is equal to ln 3/4 over -4, and this value is going to give you f prime equal to -3. So there it is. There's your answer. We're going to go to part C. Now part C says find the average value of f in the interval of -1 to 1. Now remember, average value in calculus, and I say that and I repeat that many times in class, and I think I'm hoping that at some point you will memorize this. Every time we're talking about average value, we are saying of integral from one boundary to another boundary, A to B, for that function f of x dx, and we take that derivative, integral, definite integral, and we divide by the domain, b minus a. So today, essentially what we're doing today is going from -1 to 1, f of x dx, divided by 1 minus -1. So we're really saying, and let me just even backtrack a little bit here, step back a little bit here. We are really saying is that what is this? Is integral -1 to 1, f of x dx, and take that value, we'll divide by 2. Now the challenge right now is this, is that how do we find out? So once you get this part right, you're halfway there. And you let the process kind of guide you through the calculation, right? Now when you end up with this and you say to yourself, well, okay, I want to find the integral of -1 to 1. But from -1 to 1 goes from a negative value to a positive value, and f of x is defined by a piecewise function. One is dictated, the negative value side is dictated by this function, and the positive value side is dictated by that function. So what that means is that integral -1 to 1 f of x dx is actually -1 to 0 1 minus 2 sine x dx plus 0 to positive 1 e to the -4x dx. Do you see what's going on? This function is defined by two pieces, this piece and that piece, and is centered at 0. So if we go from -1 to positive 1, we must utilize two different parts of the same function. So we can go ahead and solve this, and then take whatever we have over here, then we can divide by 2 right here. So let's try that. So here, the derivative of 1 is just x, and not derivative, integral of 1 is 1 dx is x. Integral of -2 sine x dx, this is what we will end up with. We will end up with positive 2 cosine x. Okay, and this is evaluated from -1 to 0. Plus, now integral of e to the -4x dx. So the -4 is going to come down to the bottom, so we get -4 on here, 1 over -4. And then integral of e to the u is still equal to u, so we end up with e to the -4x, and then we evaluate from 0 to 1. So, as we continue, we get 0 plus, you put 0 into x, and you put 0 into x, so you get cosine 0, and cosine 0 is 1, so 0 plus 2, minus -1, plus 2 cosine of -1. Plus, let's go to here now. We put 1 in here. We get -1/4 e to the -4. E to the -4. And then minus -1/4 e to the 0. So this is just a matter of arithmetic. So we get 2 minus and minus becomes plus, so that's plus 1. Minus and minus, so minus 2 cosine of -1. This is minus 1/4 e to the -4, and this will be plus 1/4, and e to the 0 is 1. So this will be 3. So we got 3 plus 1/4, and if you have 3 plus 1/4, you get 13/4. So you get 13/4 plus 2 cosine of -1 minus 1/4 e to the -4. So this is what we have for the integral. But notice, the average value is equal to the integral divided by the domain, which is in this case 2. So we must take this divided by 2. So average value is equal to 13/4 plus 2 cosine -1 minus 1/4 e to -4 divided by 2. And finally, let me just erase this part just so that we have an answer. So here, finally, the answer is 13/8 plus cosine -1 minus 1/8 e to the -4. Let me repeat. This problem is asking for average value. So you must have the right equation. Right? If you know this, then you can adapt to this by using your function right here. And you then notice that it is about the integral of the function divided by 2. Then you ask yourself, well, what is the integral then? And you can build this piece by looking at two different parts of this function. This is the integral, and you take the definite integral, the answer of the definite integral divided by 2, you end up with your answer. Okay?